Today I will be discussing with you Hutchinson-Gilford progeria syndrome, otherwise known as progeria. What is it? Hutchinson-Gilford progeria syndrome, otherwise known as progeria or HGPS, is a rare, fatal, genetic condition characterized by an appearance of accelerated aging in children. It was originally discovered in England, first by Dr. Jonathan Hutchinson in 1886, which was then followed up by Dr. Hastings Gilford in 1897. As stated before, it is considered the rapid aging beginning in childhood. It occurs 1 in every 4 to 8 million births, and the life expectancy for a child with progeria is 13 to 14 years old, and their death is usually due to heart attack or stroke. Now let's discuss the phenotype and genotype of this disease. For the phenotype of this disease, it is when children experience symptoms found in elderly people. Distinctive appearances these children may have are baldness, aged skin, a pinched nose, small face and jawline relative to their head size, and cardiovascular abnormalities. Some cardiovascular abnormalities include hypertension, elevated platelet counts, and elevated serum phosphorus levels, which many of these lead to heart disease and stroke, which ultimately leads to their death. However, it should be noted that this disease does not affect a child's brain function. Now on to the genotype. The gene that is responsible for this disease is the element A gene, and a point mutation occurs in chromosome 1. The element A gene produces the lamin A protein, also called progerin, which is a structural scaffolding that holds the nucleus of a cell together. This protein makes the nucleus unstable, leading to cellular instability, which leads to the process of premature aging. Sporadic autosomal dominant is considered to be the inheritance pattern of progeria, but we will get into that later. It should also be noted that this disease cannot be recessive because it cannot be inherited. Now, if you look to the image to your right, the top image is one of a healthy cell, and the bottom is one of a cell with progeria, and you can tell by the misshape of it. Let's talk a little bit about the biological pathway that a progeria cell takes. The first two steps in this process are identical to that of what a normal cell would take. The first step is the element A gene encodes a protein called prelamin A. The second step is the prelamin A has a farnesyl group attached to its end. The third step is where things start to become a little bit different. The third step of a progeria cell is that the farnesyl group remains attached to the prelamin A, while in a normal cell, the farnesyl group is removed from the prelamin A instead of remaining attached. The fourth step in a progeria cell is progerin is formed, an abnormal form of prelamin A, while in the fourth step of a normal cell, the normal form of prelamin A is formed. For the fifth step of a progeria cell, progerin anchors to the nuclear rim, while in the fifth step of a normal cell, prelamin A is not anchored to the nuclear rim. Finally, the sixth step of a progerin cell, it creates an abnormally shaped nucleus, while in a normal cell, the sixth step is that a normal shaped nucleus is formed. I briefly touched on this before, but the inheritance pattern of progeria is considered to be sporadic autosomal dominant, which means one copy of the altered gene in each cell is sufficient to cause this disorder. It is considered sporadic because it is new to the family. Previously stated, chances are 1 in 4 to 8 million births, and this is not dependent on race or gender. However, chances for another child of a couple to have progeria when one is already diagnosed raises the chances 2 to 3%. This is due to something called mosaicism, which means one parent has a genetic mutation for progeria in a small portion of their cells. It should also be noted that progeria usually occurs in families that have no prior history of the disease. Now let's wrap up our discussion by talking about the significance of progeria. Sam Burns is arguably one of the most well-known children to have been living with progeria. He delivered a TEDx talk titled My Philosophy for a Happy Life, in which he discussed living with disease and how he does not let it affect the way he lives his life. I was shown this video in my high school biology class, and it has stuck with me ever since. He is a very optimistic person despite his disease, and does not let it drag him down. This is seen with many children who have the disease, as they always seem to be very optimistic despite their terrible disease. Sam also sheds light onto the fact that despite what many people may think, these children lead normal lives just like the rest of their peers, which I believe people need to see and be aware of. In addition, through my research, I have only found one organization that is actively pursuing treatments and cures for this disease, which I find very disheartening. The organization is the Progeria Research Foundation, and so far they have been very successful in their work. Their organization helped locate the element A gene, which helped create a new test to discover progeria at a much younger age. They also discovered the first drug that is used to help treat progeria called lonafarnib, and they are currently in phase 1 of a new 2-drug trial using lonafarnib and another drug called zoledronic. The Progeria Research Foundation is making great strides in treatments and cures for progeria, and without them, many of the things we learned in this presentation would not be possible. I hope you got a lot out of our discussion today, and thanks for listening.